Howdy, y'all. Today I'd like to talk about the scientific method. Whenever I speak to science skeptics, whatever they happen to be skeptical of, inevitably the term pseudoscience comes up. And with flat earth in particular, depending on who you talk to, all manner of accepted sciences are considered to be pseudosciences. Astronomy is definitely always included in that. So because they feel that it does not follow the scientific method as they prescribe it to be, which involves an independent variable, a dependent variable, and all that sort of things. The scientific method, generally speaking, and if you've gone through college to any level, and you've taken any number of science classes, you more than likely have seen that diagram of the scientific method. It is basically ubiquitous in these classes. Effectively, what it is you see a phenomenon, or you are aware of a phenomenon. You then research what has previously been done with that phenomena and educate yourself more on the physical nature of the phenomenon. Then you create a hypothesis to explain or describe what you to explain or describe the problem that is currently arising related to that phenomenon. You then, in astronomy, develop a set of observations that you believe, when you've done proper analysis on them, will be able to answer that hypothesis, will be able to address that hypothesis. You take those observations, you analyze that data, you determine whether or not your data supports or doesn't support the hypothesis, and then you publish. If it doesn't support the hypothesis, then the diagram tells you you go back and you reformulate the hypothesis and go for. Questions in science are never that clear-cut, at least not in astronomy. And so you're always going back to that hypothesis. Even if your data suggests that you are correct, you could always refine that answer. You can always get better precision. So you're always going back to it. And you can see this if you look at scientific papers, if you look at journal articles within astronomy at the very least. The way that you're going to see them structured depends on the journal, but the way you're going to see them structured overall is you're going to have an abstract at the very top that basically describes, this is the problem, this is what I did, this is what I got, this is what I think is happening, in very short, concise statements, and very specific. The values that you have obtained are going to be listed there. Then you have the introduction. That is the place where you have researched this, you research the topic, you describe what the topic is, you describe the previous work that has been done on that topic to answer the question that your paper or your research is attempting to answer. Next section is typically the observing strategy, where you list all of your observations, or at least your observational techniques, what telescope you use, what camera you used, how many times you observe the target, that sort of thing. You also describe if you are using ancillary data, like archival data. That goes in there as well. Then comes data analysis. Data analysis is really the formulation of the hypothesis, because here you're going to talk about what model that you're going to use. And this is the sticking point that people who don't believe that astronomy is science, this is where they fall off the wagon, essentially, is that they do not understand the power of a model. And they do not understand what a model can and cannot say. And so they will just reject it wholeheartedly by saying that nature cannot be described by model. They'll throw around the word reification and all that kind of good stuff. But anyway, astronomers, scientists, will present a model. And that model will make a prediction. So you make a model of a star with spots on it, and that is going to be a prediction as to how the light is going to vary over time. You then compare your observations to those predictions, and if your observations uphold those predictions, then your model there is evidence to support that model. Is your model correct-ish? It is correct enough with relation to the data that you have gotten. No model that has been created by a human person is infallible, as we are. It is not a complete description, but it is the best description that we have at the moment. You test it. You see whether or not your model is correct. If it isn't, then you will explain what possible why your model is failing in this case. Generally speaking, if your model fails completely, you're just not going to publish. So if you're publishing, typically there is some success, but if you do have problems, then you can address what those problems are in the data analysis section. And then the conclusion is a bit longer discussion of you restate the problem, you restate what you found, and then you start to talk about the implications of that work on other questions. You might, although I don't tend to do this, or did not tend to do this, you might attempt to put forward an explanation for what it is you're seeing, give an interpretation of what it is the data is telling you. But that needs to be couched in speculative language. This is what I believe could explain this phenomenon. However, if you're a good scientist, you will also provide other explanations for how that goes, or how that could explain the results of your work. This is how science is done. This is, at least again, in astronomy, the scientific method in practice. If you want to challenge that, then my first question to you is, where did you learn your conception of the scientific method? And can you provide rationale behind why your conception of the scientific method is better than the one that is being used in modern science pretty much across the board? So, it may seem that I'm not open to that sort of conversation, but I am. I am open to having those conversations, and I actually want to have those conversations because typically the answer that I get is independent, dependent variable. Where did you learn that? From this website, which is from a college, which is written by academics such as myself. And so there's a misunderstanding of what that description actually means and what it actually applies to. So that's really all I had. But so again, if you want to have that kind of discussion, please let me know. I prefer to have it over voice rather than in the comment section, because in text you get a lot of miscommunication and so forth. So that's all I really have to say on the topic of the scientific method for now. Peace out and clear skies.